This is tricky trivia vintage. This film covers 7 British locomotives, taken as engineering decisions with dates, mechanisms, and consequences. Here is the running order. First, John Blenkinsop's 1812 rack locomotive near Leeds, built for steep colliery gradients. Second, the Great Western Railway Castle class of the 1920s, including Caerphilly Castle. Third, a Caledonian railway tank engine renumbered into the LMS after the 1923 grouping. Fourth, LNER number 4472 Flying Scotsman and the 1934 authenticated 100 miles an hour run. Fifth, the North British Locomotive Company in Glasgow and a 1904 export tank for the Madras Railway. Sixth, Peppercorn A1 number 60163 Tornado, completed in 2008. Seventh, the National Railway Museum in York, where much of this hardware survives. We take them in that order. Chapter 1, Blenkinsop, 1812. By the early 19th century, British collieries already used plateways and edge rails to move coal. The open question was whether a steam locomotive could pull economically on those lines. Ordinary adhesion depends on the weight pressing down on the driving wheels and on friction at the railhead. On steep or greasy colliery tracks, that friction often failed. On the Middleton Railway near Leeds, John Blenkinsop's answer was a rack locomotive. A toothed driving wheel engaged a rack rail laid beside the running rails. That gave positive drive for coal trains where adhesion alone was not enough. Matthew Murray of Leeds built locomotives to Blenkinsop's patent. Contemporary accounts treat them as working industrial plant, not experimental curiosities. Later mainline practice favoured stronger locomotives and better track, so rack drive faded from ordinary British railways. The lasting point is the principle: if the gradient defeats adhesion, change the drive mechanism. Chapter 2, the Great Western Castle class. After the First World War, the large railways competed for passenger revenue with faster schedules and more powerful express engines. Charles Collett's Castle class entered Great Western Railway service in the 1920s as 4-cylinder express locomotives, finished in Brunswick green. They followed the earlier Star class in design lineage and were built primarily for express routes west from Paddington. Caerphilly Castle, completed in the mid-1920s, was exhibited as a flagship example of that policy. Measured performance and publicity traveled together, but the operating brief remained haulage capacity and reliability at express speeds. The Castles competed in a wider interwar contest with the LNER and LMS. Passengers noticed the name and the livery. The operating department watched water stops, boiler performance, and the timetable. Chapter 3, a Caledonian tank under LMS numbers. Most railway work was not non-stop express running. Branch passenger trains, empty coaching stock movements, and yard trips needed engines that could run well in either direction without turning. Tank locomotives carried coal and water on the engine itself, without a separate tender. That shortened turnaround times at termini. Before 1923, Scotland's Caledonian Railway ran such tanks on local and branch duties. The Railways Act of 1921 led to the grouping of 1923, consolidating most British lines into four large companies. The Caledonian was absorbed into the London, Midland and Scottish Railway, the LMS. Caledonian Tank No. 8 was renumbered as LMS 15027. Same machine, new owner, new number series. For crews and sheds that meant new rule books and a new company identity. For the historical record, numbers like 15027 mark exactly how regional railways disappeared into national systems. Chapter 4, Flying Scotsman. LNER Class A1 number 4472 was built in 1923 for London to Edinburgh Express work. In 1934 it became the first steam locomotive authenticated at 100 miles an hour. Authenticated means a recorded run accepted under operating conditions, not a figure from a manufacturer's brochure. Gresley-era LNER Pacifics were designed for sustained high-speed service on the East Coast Main Line. Water. Troughs between the rails let a scoop under the tender refill the water supply while the locomotive kept moving. That cut intermediate water stops on long non-stop diagrams, and the system's detail matters as much as the locomotive itself. Flying Scotsman later became well known in preservation. Here it is one data point among 7, a grouping-era Pacific that demonstrated what British steam could sustain on a clear main line. Chapter 5, Glasgow Export Building. The North British Locomotive Company was formed in Glasgow in 1903 and became one of the world's largest locomotive builders. Its works produced engines for British lines and for overseas railways. Gauge is a hard constraint in that work. British standard gauge is 4 feet 8.5 inches. Export orders often specified meter gauge or other narrow gauges, along with different loading gauges and different fuel and water conditions. The example here is a 1904 tank locomotive for the Madras Railway, built to 2 foot 6 inch gauge. That was a design match to the Madras Railway's own specification, not a scaled-down version of a British mainline engine. Works numbers and export order books show Clydeside as a manufacturing hub, locomotives designed in Scotland, shipped abroad, and operated under other companies' names on other continents. Chapter 6, Tornado. British Railways ended mainline steam working in the 1960s. The last steam locomotives built for British mainline service in that original era date from around 1960. After that, skill survived in preservation workshops, but new frames and boilers intended for mainline running were rare. In 2008, the A1 Steam Locomotive Trust completed Peppercorn Class A1 number 60163 Tornado, the first new mainline steam locomotive built in Britain since 1960. Tornado is not a rebuild of a surviving engine. It is a new locomotive of the LNER Peppercorn A1 design, using original drawings as the baseline. The builders then had to solve a separate set of modern problems, sourcing materials, managing workshop capacity, and meeting acceptance requirements on a railway with contemporary signalling and inspection rules. That combination makes 2008 both a heritage milestone and a manufacturing one. Chapter 7, the National Railway Museum in York. The museum holds locomotives, rolling stock, and records from Britain's railway age in large covered halls, including the Great Hall. It is a national collection, engines that moved mail, freight, and passengers, kept for study and public display. Builders' plates, drawings, and official photographs sit alongside the machines. Claims about class, date, company ownership, and rebuilding history can be checked against surviving physical objects. Prefer the plate and the record over the legend. Taken together, the 7 examples form a short technical history. Early industrial haulage sold steep gradients with rack drive. Interwar express companies competed with named classes and measured speed. The 1923 grouping folded regional identities into for large railways. Glasgow exported locomotives to overseas gauges. The 21st century built a Peppercorn Pacific from drawings and workshops. York preserves the hardware so the record stays inspectable. Stay curious.